So the climate talk discussion that we had was split into basically three parts. Firstly, I wanted to describe tools for thinking about the climate crisis, and then we had a discussion about what we should do as individuals, and then what we wanted society to do, and then finally I had a slide on how to stay positive in this situation. So first I asked the people in the group how worried they were about the climate crisis as a poll that we did on Zoom, and it varied from slightly worried, well, actually not worried at all, slightly worried, very worried, or off the scale. And most people were slightly worried or very worried. And I thought that this was good because it is right to be worried about the current climate crisis, but not that you're so worried that you can't act and you can't respond to the emergency. What I wanted people to do was to look at the climate crisis through the prism, if you like, of the carbon cycle. And this is the carbon cycle illustrated here. And that green tree you see there represents us, because we on Earth are either a photosynthetic organism, a plant, or we eat one, or we eat one that eats one. So we are that plant. And in the carbon cycle, what you can see is that carbon dioxide gets combined with organic molecules within the photosynthetic organism. And this process is driven by energy from the sun. And in this way, carbon dioxide, which is free carbon, gets combined with other carbon atoms as carbon-carbon bonds, and in so doing, energy from the sun is trapped in those carbon-carbon and carbon-hydrogen bonds in the organic molecules. And this is a process called photosynthesis. As part of it, oxygen is released, and this has been going on for about 3.5 billion years on our planet. And in order for us to do things and have energy, we need to break those carbon-carbon bonds and release that energy. And in so doing, we require oxygen to do that. And this is the carbon dioxide is re-released into the atmosphere. And this cycle has obviously been going on for 3.5 billion years. And as a result of this process, everything in the natural world that you see is made up of building blocks from photosynthesis. We are utterly dependent on this process. And there have been variations. Sometimes the carbon dioxide levels have been high, and we've had hot house Earths, and sometimes they've been low, and we've had ice ages. But the important point to note is that changes in the cycle have happened slowly. They happen over millennia or even longer. This isn't a quick process naturally. Just to show a molecule of carbon dioxide. In the center there you see the carbon atom, and it's joined to two oxygen atoms. And a property of carbon dioxide is that it can absorb energy from the sun itself. And this is not chemical energy, this is physical energy. And when it absorbs this energy, it vibrates and jiggles about, and that is what causes heating. But molecules, being molecules, are quite fussy. They live in the quantum world, and they absorb energy of a particular wavelength. So in the case of carbon dioxide, energy from the sun of a shorter wavelength passes right through the carbon dioxide. But when it reflects off the land and the oceans, it reflects off with a longer wavelength, and it's that wavelength of light which is absorbed by carbon dioxide, causing it to vibrate and move around, and that is why you get atmospheric heating. And this effect is known as the greenhouse effect. If we return to the carbon cycle, obviously this process of photosynthesis and then the re-release of energy that we require to live and grow, this happens over a period of time, let's say of days, weeks, and our lifetimes. In our case, up to 100 years or so. And but as well as this process, a much slower process also takes place, whereby some of the organic matter sinks down and is buried in the ground. And in this process, this matter is subjected to heat, to pressure, and importantly, to vast amounts of time, up to 1 million years now. And in this process of sedimentation and the long chemistry that takes place, the organic matter its chemistry is simplified, so it's really just now strings of hydrocarbons, essentially just the carbon-carbon chains. And this constitutes the fossil fuels, oil, coal, and natural gas. And they accumulate over millions of years. And what's important to remember is that those carbon-carbon bonds in the fossil fuels are the entrapped energy that was originally from the sun. And what we've learned to do in industrial times in the last, let's say, 250 years is to extract the energy from these fossil fuels. And just as we're dependent on the carbon cycle, now we've become dependent on these fossil fuels for our industrialization, our cities, our transport, etc. But not only the life in towns and cities, our agriculture has also been industrialized. It also depends on energy, vast amounts of energy stored away that we're now extracting. And we use that for agriculture to grow our food. And in addition to that, the livestock that we cultivate, they release another greenhouse gas called methane. And if there's one thing I want you to remember, it's that cows burp, they don't fart. And when they burp, they release methane, which is essentially the same as natural gas. And this also is a greenhouse gas. It has the same effect as carbon dioxide. In fact, it's slightly more potent. The good thing about methane is it doesn't remain in the atmosphere as long as carbon dioxide, and there's much less of it compared to carbon dioxide. But nonetheless, it's another greenhouse gas. So some of the carbon dioxide is reabsorbed. I mean, you might ask me, surely if this carbon dioxide is being released, surely it can go back into the carbon cycle. And as part of preparing for this talk, I realized that actually quite a lot of it does. And it goes into these carbon sinks, which are represented by this green lozenge here. And these sinks are things like the Amazon rainforest, but also good old British peat bog is also an excellent sink, as it's called, for carbon, where the carbon is reabsorbed in a process of carbon fixation, i.e. photosynthesis. And in these sinks, it can be stored over a period of thousands of years. The trouble is the expansion of our cities and the expansion of our land use from things like farming reduce the health and availability of these carbon sinks. We have a problem with there being accumulations of carbon dioxide in our atmosphere. And over the last hundreds of thousands of years, the levels were stable at around 280 parts per million. That parts ppm. So parts per million literally means if you took 1 million molecules from the air, 280 of them would be carbon dioxide. So carbon dioxide is still a trace like gas if you're in our atmosphere, but nonetheless, it's enough to have this effect. The problem is, at the moment, the levels of carbon dioxide are 415 or more parts per million, and this is the highest it's been for 5 million years. And 5 million years ago, life was very different. We weren't around. We split off from chimpanzees and bonobos around 6 million years ago. 5 million years ago, the Earth was 2 to 3 degrees warmer, and the seas were 25 meters higher. There were small shrubs growing near the South Pole, for instance. A very different world to the world we live in today. So we do have a crisis on our hands. And the possible climate futures, as laid out by the recent report from the Intergovernmental Panel on Climate Change, well, they show if we can drastically reduce our emissions, we can limit global warming to 1.4 degrees average increase in temperature. However, if we carry on as we're doing, it's going to be more like 2.7 degrees by the end of the century. And if we really accelerate our emissions and go ahead and extract and burn all the fossil fuels, we're looking more like 4.4 degrees by the end of this century. What does this mean? You probably know already. More extreme weather. Worryingly, as the global warming proceeds, the carbon sinks will work less efficiently. There'll be ocean acidification, putting stresses on our marine life. Sea levels are predicted to rise possibly by 2 meters by the end of the century. Interestingly, the report said that by the year 2300, it could be 20 meters increase in sea levels. And we're going to have stresses and difficulties actually growing our food. So these are all reasons for concern. I wanted us to have a discussion about what we can do as individuals about this situation. And at first, I wanted people to understand what their carbon footprint was. So your carbon footprint is the amount of carbon dioxide measured in weight that you release into the atmosphere. And this is carbon dioxide from the burning of fossil fuels. And as a citizen of the United Kingdom, on average, our carbon footprint is 10 tons of carbon dioxide per year. So I did that just by looking at our total carbon footprint for the UK and dividing it by the number of people in the UK. So that's a useful number to hold on to. Right, it's a sort of rough estimate, but 10 is easy to remember. So I then asked people, which of these most reduces your carbon footprint in a year? Is it going vegan for a year? Is it one less long-haul flight a year? Or is it giving up the car for a year? And well, the people's opinion were mixed, but the answer is actually giving up the car for the year. That would save you 2 of your 10 tons of CO2 per year. That was a slight surprise to me. It's more than one long-haul flight, but one long-haul flight is 1.6 tons. And people were interested in the fact that buying an electric car was not quite as good as being car-free, and that's because, of course, there are some carbon footprint in the manufacture of cars. And well, there were some other interesting things to look at there. So the vegan diet did reduce it quite a lot, but only 0.8 compared to being car-free. Obviously, this source is from the BBC, and that they took it from the Centre for Research into Energy Demand Solutions. This, I felt, was a very interesting slide to show. This was the carbon footprint information from gov.uk. And you can this shows the carbon footprints for 1997, 2004, 2017, and 2018. And the really interesting thing is, if you look at green, right, that's our transport, so that's our cars, etc., and that's quite small. And also yellow is our household heating emissions. Actually, most of our carbon footprint, much to my surprise, is from things like UK production, manufacture and consumption, and white. This is imports. So this was a source of dismay, but also hope and opportunity to me, because often I've looked at people with electric cars and I've thought, well, that's good for you, but I can't yet afford an electric car, and I can't change easily heating my house. But actually, we need to also focus very much on our behaviour as consumers as well, in terms of reducing our carbon footprint. There lies an opportunity. So we then had a discussion on, and thinking about this point, and I would encourage you to think about this. Do you have a favourite climate change tip that you wish more people knew about? And many ideas came about through this discussion, and it wasn't hard to think of lots of things people can do. And then I wanted the group to think more widely about what they would hope churches, councils, and governments should be doing about the climate crisis. And as a preface to thinking about that, I just wanted to know what people felt that the current, or I asked this question, what percentage of Britain's UK electricity was generated from fossil fuels in 2019? And people didn't actually know, I didn't know, but the answer is actually 43%. And that was much higher actually than I thought, because there's been a lot of talk about renewable energy, a lot of talk about wind farms, solar, but actually it was 43% fossil fuels in 2019, and it does vary from year to year. For instance, at the time of giving the presentation, there was a bit of a wind drought that had just gone on, so there hadn't been much generation from wind energy. So people had gone back to relying on natural gas mainly in those kind of situations. The Synod of Scotland, of the United Reformed Church, and the United Reformed Church in general want us to be carbon neutral by 2030. So there's the challenge laid out to us. And I put the point that at Augustine United Church, we might be close to this actually, because most of the energy our church gets is electric, and electric generation, despite what I just said on the last slide, is becoming more and more green, more and more, in the UK at least, relied on renewable sources of energy, such as offshore wind. However, this might be more of a challenge to achieve if we were asked to examine the carbon footprints of the people who attended the church, i.e. the congregants. That might be a more difficult thing to look at. I also made the point that Augustine United Church became part of the eco-congregation movement in 2009. And in 2018, we were awarded an eco-congregation silver award. And a lot of people did a lot of work into preparing our evidence to get this award. In particular, our church secretary, Kath did a lot of work in order to apply for the Eco-Congregation Silver Award. And as part of that, we said that we examined a lot of what we did as a church, a lot of our activities, and also we sort of made the point and we pledged that we would spend a lot of time raising awareness and having meetings such as this to continue to think about the climate emergency. That was all part of what we need to do in order to live up to the Eco Congregation Silver Award. Then had the final discussion point, which is what do you most wish churches, councils and governments would do about the climate crisis? I think this is really an important thing for us to all think about. It's easy to state what the climate emergency is, and I say easy, but it also causes a lot of mental distress, if you like. But you can sort of refocus and cope with that stress by turning your attention to, well, what should governments, what should councils, what should churches, and what should we as individuals be doing? That's where the focus should lie. So I then had a final slide, which is ideas for mentally dealing with the crisis, because it does cause a lot of angst. And my first point was educate yourself. I learnt things in preparing for this talk. One thing was I thought that single-use plastics wasn't really to do with climate change as such, because the plastics themselves don't end up as carbon dioxide in the atmosphere. But I was wrong, because each single-use plastic item necessarily requires a lot of fossil fuel in its manufacture, transport, generation, etc. Secondly, every little helps. Everything you can do helps in this situation, whether it's protesting, whether it's changing your behaviour in some way, or whether it's putting pressure on the government to change. It all adds up and helps. The third thing to think about is that things are happening. People are worried about this. People are building offshore wind farms. People are developing new techniques. More and more people are going over to electric cars. And it was really great that China has offered to be carbon neutral by 2060. If they can live up to that, that is good. My final point was never give up. There are some people that say that once we reach this point or that point, there will be no hope. But I much prefer the environmental scientists who know all about the situation, who say that, however bad it gets, I will never give up this fight. Even if the world gets 4 degrees warmer, I will still be there saying that we need to protect nature, we need to protect biodiversity, we need to do what we can do. So thank you very much for listening to this talk. I hope it's been useful. I'd like to end, if I may, with a prayer. Loving God, we love you, we love our planet, we want to look after it. We love the people in our planet. We don't want anyone to stumble. Help us to listen to each other. Amen.